Okay, ladies, gentlemen, I'm going to be working on our next unit, which is trig derivatives. And in the note that I provided, it showed by first principles that the derivative of sine x is cos x. So that's a really important derivative that establishes all the rest. That one's done by first principles. Maybe in a later video I'll go through that in more detail. That allows us to come up by using trig identities for the derivative of cos x, which is minus sine x. And at the end of this video, or towards the end of this video, I'll show you where that one comes from through trig identities. But for now, I would just say make sure you understand that the derivative of sine x is cos x and the derivative of cos x is minus sine x. And I'm going to work through a bunch of examples to help us with that. And hopefully later I can shed some more light onto where those derivatives come from. But let's just work through these examples that I have and see what happens. So the first one, pretty obvious, I hope. F of x is equal to sine x, just like this one. So the derivative f prime of x will be equal to cos x. And you notice with all of these first examples on this page, the argument we call it is just x. Derivative of cos x minus sine x. So what happens if we combine that with more rules from earlier units? This is an example of a product rule. So I'm going to use the product rule on this one. Y prime equals first x squared times the derivative of the second, which is cos x, plus the second sine x times the derivative of the first, which is 2x. And if you look at these two expressions, you can common factor out an x. So y prime, maybe I'll do it in a couple of steps, looks like this: x squared cos x plus 2x sine x. So you'll notice that this cos has an argument of x, sine of x. You can't common factor the argument, but you can look at the algebra in front and say, okay, for that algebra, I can common factor out an x. And you're left with x cos x plus 2 sine x inside the brackets with the common factor of x. This next one is an example of a quotient rule. So y prime is equal to denominator x squared times the derivative of the numerator minus sine x minus the numerator cos x times the derivative of the denominator 2x all over the denominator squared. So looking at these two groups on the top, I can see again I can common factor out a x from each of them. I'm going to try to do this with limited space, so I'm going to take out a minus x from each group, and when I do, I'm left with x sine x plus 2 cos x all over x to the fourth. So see if you can follow the common factoring on the top, and then we recognize we've got an x in both of these, both numerator and denominator, so I'm going to leave it like this. All over x cubed. So I canceled that x with that and made the exponent 3. Here are some examples where the argument isn't just x, it's x squared, 3x to the fourth plus 8, and so on. So we're going to work at this one by doing it like a chain rule question. So y prime equals the derivative of cosine x. Well, the derivative of cosine is minus sine. And you'll notice that the argument in the question is the argument in the answer, unless we use identities. But here's the important trick now. We have to multiply it by the derivative of the argument. We used to say multiply by the derivative of the brackets, but now inside here we have an argument and you multiply it by its derivative. So the derivative of cos is still minus sine, the argument stays the same, and if the argument is complicated like this one, we multiply by its derivative. So y prime equals negative 2x. This is all algebra that I put in front, and then the trigonometry at the end. This one is much like it. Y prime equals the derivative of sine is cos. The argument in the question stays the same, but the way you compensate for that is by multiplying by the derivative of the argument. Just like we did in this example right here, the derivative of this argument is going to be 12x cubed. So y prime equals 12x cubed cosine 3x to the fourth plus 8. This one is a lot more complicated because of this exponent 4. This means cos to the 4th. And in fact, we're going to write it as such. I'm going to rewrite this question so it looks like this, not taking the derivative quite yet. Cos of x squared plus 2, and then a big square bracket to the 4th. That's what this means. Cos to the 4th means cosine of the argument all raised to the 4th. And now we can do it like a chain rule question. Y prime equals, bring the 4 down in front. We would say 4 hot dog to the exponent 3 times the derivative of what's inside the brackets. Well, what is the derivative of cosine? Derivative of cosine is minus sine times the derivative of the argument, 2x. So we're going to rearrange this from the least complicated to the most complicated. So you're going to see the algebra. We've got a 4, a negative sign, and a 2x. I'm going to put that all in front. Y prime equals negative 8x. And then I'm going to put times the sine of x squared plus 2 times the cos cubed, now putting it back in its original form, x squared plus 2. So that's the derivative of that complicated expression using the chain rule and taking the derivative of the argument. Let's see if we can combine those with some more. I think these are the next questions that I wanted to do right here. Let's try this one. This is a product rule again. X cubed times sine of x to the 4th plus 7. So y prime equals first x cubed times the derivative of the second. The derivative of sine is cosine. The argument doesn't change. So first times the derivative of the second. The argument is complicated, so I'll multiply by its derivative. First, derivative of second, plus second times the derivative of the first. So let's look at these two groups. I can see y prime having 4x cubed times x cubed is 4x to the 6th cos x to the 4th plus 7 plus 3x squared sine x to the 4th plus 7. Y prime equals x squared, common factor, 4x to the 4th cos x to the 4th plus 7 plus 3 sine x to the 4th plus 7. So there's the common factor, x squared, that I took out of this group, and everything else fell into place there. Notice that you never touch the argument. You can't common factor or say that belongs common to both of them. The word cosine always has an argument that follows. You can't common factor out from it. Here's another one, another chain rule question. Let's see what we can do with this. Y prime equals 4 hot dog cubed. So this part doesn't change. We leave it the way it is. Times, and now we'll look at the derivative of what's inside the brackets. Well, what's the derivative of that? The derivative of x squared is 2x, and the derivative of cos x cubed is going to be negative sine x cubed times 3x squared. So let's see if we can simplify that one a little bit. There's not tons to do. I see y prime equals 4. Then I'll use the round brackets. 2x minus 3x squared sine of x cubed. And then we have x squared plus cosine x cubed all to the 3rd. The only other thing I can see to do here is common factor out in x, so that will be my last line. Y prime equals 4x, and that leaves you with 2 minus 3x sine x cubed times the square bracket all cubed, x squared plus cos of x cubed. So there's another derivative. Here is one that's quite interesting. It has the argument of sine being cosine. and the argument of cosine being x squared. So this is the sine of, not sine times, but the sine of the cos of x squared. So let's work through this one. I've got that same starting point with exponent 4, so y equals sine of cos of x squared, and that exponent goes out here. Y prime equals 4 hot dog to the third, the sine of the cos of x squared, times the derivative of what's inside the brackets. Well, the derivative of sine is cos, and then we have to take the derivative of this argument, and the derivative of that argument is negative sine x squared times 2x. So that's why that one gets complicated. It's sort of like a telescope. You see that you keep adding these little parts because of the compound nature of all of the arguments. So y prime equals negative 2x times 4, negative 8x times the sine of x squared times the cos of x squared times the bracket sine cubed cos of x squared. We don't really need those square brackets. One more of this type. This one is interesting. You can look at it as a product rule right now, or maybe you can identify that as an identity. And when questions pop up like this, like we have on our identity sheet, you want to use identities to simplify them. So before I take the derivative, I'm going to recognize that rather than using the product rule, I can simplify this one as y equals the sine of 2x. So now I've eliminated using the product rule. I used an identity. Y prime equals, what's the derivative of sine? Cosine 2x times the derivative of the argument, which is 2. So y prime equals 2 cos 2x. An interesting thing you might want to do now is to pause and take this one and take the derivative as the product rule, and recognize that when you do the product rule on this one, that you can simplify it and substitute using identities and get the same answer. But this one was supposedly easier to do. A few more boards here quickly. Here's one where it's going to be implicit differentiation. Implicit means that it doesn't say y equals, it says the sine of something, sine of y, cos x is on the other side, y's and x's are all interdispersed. So I'm going to take the derivative of this one using implicit differentiation. The sine of y squared is the cos of y squared times the derivative of the argument. Well, what's the derivative of y squared? Back from unit 2, we learned the derivative of y squared with respect to x is 2y times dy over dx. So this part right here is the derivative of the argument. Equals, well, what's the derivative of cos of 4x? Negative sine 4x times 4 plus 6x. So as we simplify this side right here, we have a negative 4, putting this and this in front, negative 4 sine 4x plus 6x, and then I recognize that I'm going to divide here to say dy over dx equals all of that divided by 2y cos of y squared. Argument in the question, argument in the answer. Argument in the question, argument in the answer. They don't change. Here is a product rule on both sides. Let's see what happens with this one. Y first times the derivative of the second, negative sine x, plus second cos x times the derivative of the first, dy over dx, equals x first times the derivative of the second. The derivative of sine y is cos y times the derivative of its argument is dy over dx minus second sine y times the derivative of the first, 1. So let's see if we can simplify that a little bit. We've got negative y sine x plus cos x dy over dx equals x cos y dy over dx minus sine x. So I'm going to move the terms with dy over dx to the left-hand side. I'm going to leave cos x dy over dx over here. I'm going to transpose minus x cos y dy over dx to the left-hand side, and that's going to equal positive y sine x, moving this term over to here, minus sine x. And I'm running out of room a little bit here, so I want you to imagine common factoring dy over dx out of this group right here. And when you do, you get cos x minus x cos y equals y sine x minus sine x. And then you just need to take this part and divide it over here. So that your final answer, maybe I can write it right here, would look like this. dy over dx equals y sine x minus sine x over cos x minus x cos y. One more. I want you to take a look at this one right here. It is going to prove to you that the derivative of cos x is negative sine x. So let's start with this. I've left vacant a line above, but let's begin by taking its derivative. So y prime equals the derivative of sine is cos. The argument stays the same, times the derivative of the argument. And the derivative of the argument is negative 1. So we could say y prime equals negative 1 times the cos of pi over 2 minus x. Well, let's investigate this a little bit further. Let's see if we can use some identities. Look on your identity page, on the bottom part of it. Can you find the sine of pi over 2 minus x? Does it have an equivalent expression on there? And if you look carefully, you can see that sine of pi over 2 minus x is equivalent to cos x. So really the idea was, let's start with cos x and let's use an identity and change it to this. Because we know the derivative of sine, we want to express cos in terms of sine. We take the derivative of that expression and we get this as an answer. Well, how much further can we go with that? What can you say about y prime? I see the negative 1. Can you find an identity for this? Look on that page. What's the derivative of cos pi over 2 minus x? Can you see that it's sine x? So in truth, the derivative of y equals cos x can be shown through identities and taking the derivative of sine, that the derivative of cos x is just negative 1 sine x. Last question that I'm going to do is like question number 4. It looks like this. Y equals sine squared of x, and it says find the equation of the tangent line at x equals pi over 3. So let's see if we can begin by taking the derivative of this expression. Y equals the sine of x all squared. So that makes y prime equal to 2 sine x times the derivative of sine x, which is cos x. So that's 2 sine x to the first, like the chain rule, times the derivative of what's inside the brackets. So y prime equals 2 sine x cos x. Let's see what happens when we put pi over 3 in there. At x equals pi over 3, y prime will be equal to 2 times the sine of pi over 3 times the cos of pi over 3. So looking at this special triangle here, you can see that the sine of pi over 3, opposite over hypotenuse, is root 3 over 2. And the cos of pi over 3, adjacent over hypotenuse, is 1/2. All in all, when you multiply that all out, you get y prime equals root 3 over 2, canceling this 2 with this 2, for example. So there's the slope. In order to find the equation of the tangent line, we also need to know the value of y. So let's see what this is equal to. Y is equal to the sine of pi over 3 all squared. So pi over 3 we've established, the sine of pi over 3 we've established to be root 3 over 2. And we want to square that because it's not just sine of pi over 3, but the sine of pi over 3 all squared. So y is equal to 3 over 4. So we have an ordered pair, pi over 3 comma 3/4, and we have a slope. So let's plug that in to our equation of a line formula. Y minus y1 equals m onto x minus x1. Y minus 3/4 equals m root 3 over 2 x minus pi over 3. Y equals, distribute that in, you get root 3 over 2x. Multiply these together, you get minus pi times root 3 over 6. And transpose this guy over and you get positive 3/4. And that's how we want to leave it, as an exact value. I'll try to post this soon. Have a great day.